So this is the second video for our topic of higher degree equations. And in this video, we're going to focus on solving by factoring. This is a pretty straightforward concept. We'll give you sort of a rundown. We're just going to do 4 examples. The last 2 examples especially have some unique properties that you're going to want to make sure that you see and you're familiar with. So if you do find that the first 2 are a little bit slow and too easy for you, then feel free to skip to the end, but please don't skip the last 2 examples. Okay, solving by factoring involves 3 basic steps. We need to get a 0 on one side of the equation, then we need to factor the other side. And we use this property called the zero product property that says that if you've got a 0 on one side, you can take your factors on the other side and set each one individually equal to 0. So basically for each factor you create, you're going to create an equation of its own. Now since the factors are simpler than the original equation, these equations will be much easier to solve. So this is a quadratic equation, which means that we could get a 0 on one side and solve using the quadratic formula. However, if you're good at factoring, and I hope that you are, solving by factoring is usually much easier, much quicker than solving using the quadratic formula. All right, let's go ahead and start this up. We need to start by getting a 0 on one side of the equation. So I'm going to get rid of this -1 by adding 1 to both sides. And that's going to leave us with the equation 3x squared minus 18x plus 24 equal to 0. So we have just done step 1 here. We got a 0 on one side of our equation. All right, and the next step, we need to factor the other side. So I'm going to try and factor. Now, before I get into actually factoring this out, before I get into factoring the trinomial, I should look for a GCF, and I do notice that we have a 3, 18, and 24, which are all divisible by 3. So let's start by pulling out that GCF. That's going to make our factoring even easier. All right, and then let's keep factoring. We're going to leave the 3 here. And we've got a simpler trinomial to factor at this point. X squared, so x times x. We want factors of 8. And we should be able to do -2 and -4. All right, so we have successfully factored in these 2 steps here. This was the second phase of this problem. Our final phase, we're going to set each of our factors equal to 0 and solve. Now, technically, we should set all 3 of these factors separately equal to 0. And I'm going to go ahead and do that. And any of these that give us solutions, we're going to include that solution in the final solution to the equation. Now, check out this first equation here. 3 equals 0 is not even a true statement. There's not even an x in there for us to solve for. Therefore, we're actually just going to ignore this guy. Because 1, it's a false statement, and 2, there's no value, or there's no x to solve for. So we do have 2 equations that we can solve. A couple quick steps of algebra. Adding 2 to both sides is going to get us x equal to 2. Adding 4 to both sides is going to get us x equal to 4. So our final solution to this equation is going to be x equals, and I'm going to use set notation here to denote that we have more than one answer. X equals 2 and 4. Okay. Second example, this one's nice because it's already been set up for us. It's equal to 0 already. So the first step is done. Next, we need to go ahead and factor. So it's really the first step that we're doing in this one. And we'll go ahead and do that here. Now I'm looking for a GCF because that's always the first thing we should look for when we're factoring. And I do see that we can pull an x out in front. That's going to leave us with a 2x squared minus x minus 6. And we should continue factoring here. All right, so I'm going to need a 2x squared. That's going to be 2x times x. And we have a minus 6 there, so we need factors of 6. How about 3 and 2 And careful with our signs to make sure that we get what we need to, and yes, that should work. Okay, so that was our factoring step. Now it is time to take and set each factor equal to 0. We're going to do that in our next step here. Now I actually have 3 factors again this time, which means I'm going to get 3 different equations all equal to 0. X equals 0, 2x plus 3 equals 0, and x minus 2 equals 0. Okay, and I need to solve these. And in this case, I'm actually going to end up getting 3 different solutions. X equals 0 is going to be one of my solutions. We don't need to do anything to solve that. So 0 is one of the solutions. We'll do a couple steps of algebra here. Subtracting 3 from both sides will get us a negative 3 over there. Dividing by 2 will get us negative 3 halves. So my second solution is negative 3 halves. Last one, we just need to add 2 to both sides. X equals 2. And there we go. There's our 3 solutions. So writing those in set notation to denote that we have multiple solutions. I'm going to put them in numerical order from the smallest to the largest. Not necessarily required, but it's good practice. And that's going to be our final solution. Okay, we've got a couple more here. Following the exact same steps. We already have a 0 on one side. Now, this one's going to be a little bit weird because that is a sum of cubes. So you need to go back to factoring sum of cubes. And if you need to review that, feel free to go back to the previous unit and check out those videos. All right, so I got x cubed and 27. My building blocks are x and 3. Let's do my signs first. Same, opposite, always positive. That's the SOAP mnemonic. Same, opposite, always positive. SOAP. And then we're going to use that x and 3 to build out our factors. X and 3 get copied there and there. X and 3 get squared there and there. So x squared and 3 squared, which is 9. And in our last spot, x and 3 get multiplied together, which just gives us 3x. All right. So that is factor. Now, if you remember from the previous unit, we said that if there was no GCF in the original, which there is not, then this is never ever going to factor. So that is not going to factor any further. That's as factored as it can get. So at this point, we can go ahead and set our 2 factors, each individually equal to 0, and solve. X plus 3 equals 0. X squared minus 3x plus 9 equals 0. All right, let's solve this first one. That's easy. We'll just subtract 3 from both sides. We'll get x equals negative 3. So we've got one of our solutions. Now the second one is a quadratic, and we know it doesn't factor, but we still have to solve it. That only leaves us one option. We are going to have to use the quadratic formula to solve this equation. I'm going to have to find values for a, b, and c. A is going to be 1. B is going to be negative 3. And C is 9. All right, so this is going to take us a little bit longer than the first factor to solve, but we'll stick it out and get it done. Quadratic formula. Let's set up my general form. I'm making mistakes. All right, let's try this again. Setting up my general form. Just to get my structure set up, then we'll come back and fill in the values where they belong. So I've got b values here and here. We want to put our a value here and here. And our c value goes over here. All right, we're going to be very careful as we simplify this. Watching out for those signs. Minus a negative 3 is going to be a positive 3. We're squaring a negative 3. That's going to give us a positive 9. And then I'm multiplying here a negative times a couple positives. That's going to turn out to be negative. And 4 times 1 times 9 is 36. The bottom, 2 times 1 is easy. That's 2. Okay, let's keep going. We can do 9 minus 36, that's negative 27. So it's looking like we're going to get some imaginary solutions here, and that's fine. We need to try and simplify that radical negative 27. Now, I know that the negative is going to come out and become an I on the outside, so I'll go ahead and do that first. And then I'll deal with the 27, and 27, radical 27 simplifies into 3 radical 3. So I'll have a 3 moving to the outside to join that I, and a 3 left-hand side of the radical. And that's all over 2. Last thing I'm going to do is let's see if there's anything that I can factor out of both the top and the bottom so I can cancel. Now I could factor a 3 out of both of these terms on the top. So I could pull a 3 out, but that's not going to cancel with anything in the bottom, so there's really no need to do that. I can tell that nothing's going to cancel, so let's just go ahead and call it a day. That'll be our solution. Actually, that is not our solution, and this is a common mistake. That is part of our solution. Remember that x equals negative 3, way up here, was also part of our solution. So if I wanted to include the entire solution, I would list negative 3 and the result of that quadratic formula. Keep in mind that this result here of the quadratic formula does actually represent 2 solutions. There is a positive version and a negative version. Okay, and last but not least, we've got a 3rd degree equation here. This one's looking kind of nasty. It's got 4 terms. So the tool that we're going to use at this point would be factoring by grouping. We'll start by grouping our first 2 factors together, second 2 factors together, pulling out a GCF from each one of those. So, a moment. So the first 2 factors, we've got a GCF of x squared that we can pull out the front. That's going to leave us with an x plus 2. In the second set of factors, we can pull out a 2. And I'm actually going to pull out a negative 2 from this, because when we do factoring by grouping, we want the thing that's left over inside the parentheses to be the same for both of those groups. So in order to get the x plus 2 again, I have to pull out a negative 2. All right, so now we can take that x plus 2 and pull it out in front of the entire equation. So kind of like a big GCF out in front here. And that big GCF, the thing that was in common was the x plus 2. So we pulled that out in front, and what's left over inside after we pull that out of there is an x squared minus 2. All right, now that's as factor as it can go, so we can go ahead and set up our 2 equations, one for each of our factors. We have x plus 2 equal to 0, and we have x squared minus 2 equal to 0. The first one's really simple to solve. Just subtract 2 from both sides. You've got your first solution, which is x equals negative 2. Now the second one, we're going to end up using a square root to solve this. But there's a common error that comes up here, so pay attention to this. We're going to get rid of the negative 2 first by adding it to both sides. It's going to give us an x squared equal to positive 2 over here. And then we are going to take a square root. Now when you take a square root to get rid of a square on a variable, you have to consider both the positive and the negative version as of the resulting on the other side. So yes, the radical does cancel the x over here, but we actually end up getting 2 solutions from this, both positive radical 2 and negative radical 2. So our final solution here, we have 3 distinct solutions. X could be negative 2, it could be negative radical 2, or it could be positive radical 2. Now you could write that way, or you could write it as negative 2 comma plus or minus radical 2. These 2 things are equivalent to each other, as long as you recognize that there are actually 3 separate solutions to this. All right, thank you for your attention. Have a great day.